Aquaria victoria, a fine specimen also known as a crystal jelly, a spineless organism with very special properties. These jellyfish generally grow to a size of 5 to 10 centimeters in diameter and are found in the Puget Sound of Washington State, as well as southeastern Canada. Such a special organism that Edward Miller and I decided to approach several different students. Very simply, we asked, do you know what Aquaria victoria is?
No, not really.
Huh?
Not really. What jellyfish?
No.
What? What's my line again?
What? You may also be asking questions such as why they are so important. Like most of their relatives, it is almost impossible to see through ocean waters unless aided by special lighting. They hold a unique protein known as green fluorescent protein, or GFP. This protein gives off a fine fluorescent light that aids them in seeing through dark ocean waters. GFP also is inserted into a gene that is being transcribed, causing it to glow green under an ultraviolet wavelength of light.
It is genetic engineering. You go through a series of processes that allow for the transformation of a bacteria by the incorporation of a gene that comes from a jellyfish into the bacteria so that the bacteria can fluoresce, just as a jellyfish would. The way you test this will be shining the bacteria colonies under UV light, a low band UV light, and basically that's what you're looking for, to determine whether your bacteria colony accepted the gene or did not accept the gene.
Fascinated by Crystal Jelly's astonishing abilities, our team decided to bring this experiment into action.
250 microliters. You guys that Wait.
Our mission was to make E. coli glow, as Aquaria victoria do in their ocean habitats. We used many materials such as pipettes and an incubation system to perform this task. The bacteria encircles the colony, it's still alive, and we're about to open it up, so.
That's disgusting.
We spent hours injecting enzymes to the E. coli colonies. If we disregarded any of the steps or made false movements, all would be lost. Each step was done very precisely and carefully to ensure success. We immersed plasma inside each tube and placed it in ice for 10 minutes. We then placed them into a water bath and heat shock for 50 seconds and quickly returned them back to ice. We then inserted the enzymes from the tube in the 4 agar plates and spread the suspensions all around the surface. After all the main tasks were completed, the 4 agar plates were then incubated overnight. The next morning, the results were in.
Set it on the table, because of the black background.
This fine green fluorescent light you are seeing is made of GFP taken from Aquaria victoria, producing the same effect as the animal itself. GFP can also be inserted into a cloned animal cell, making it turn green under a black or UV light. Though this has been a great leap in the scientific community, these animals are known to be much thinner than their regular counterparts and seem to grow more slowly.
Has it been incubated? It's been incubated.
Luckily, we were able to experience this amazing find on a smaller scale, among many other phenomenal experiences we as students have had.
Just scoop up one little dot basically is what you're doing, because each dot represents a colony.
We did in-depth research on the events of the Holocaust. We solved a murder. We went to Marfa, Texas, where film history was made. If it is unsolved, if it has changed our world, we will be there. We are the mass communication and media magnet.
Oh, I said stop.